This is the part 2 of the day 1 of the LeetCode series that I am just starting. And the question here is today's daily problem, that is count squares and triplets. Here we have been given the question that is a square triple ABC is a triple where A, B and C are integers and A squared plus B squared equals to C squared. Given an integer n, return the number of square triples such that A, B, C lie between the range 1 and n, and in this question 1 and n are inclusive. Talking about the example 1 that is given here is n is equals to 5. The output is 2. That means the square triples that are possible and that satisfy the equation are 3, 4, 5 and 4, 3, 5. The most basic Pythagorean triplets, we all know that. So the brute force approach for this is going to be the following. So here I have initialized a count variable which will be counting the number of triples possible, basically. The first loop here represents the value of the first integer given here, that is a, and it would be going through iterations for every possible value in the range 1 n, and n is inclusive. For the second variable, that is b, we have created another nested loop that is for int j is equals to 1, j is less than or equal to n, and j plus plus. Similarly, for the third one, we have created the third nested loop. So in the third nested loop, we have simply just applied the formula that was given in the question, and if the condition is satisfied, the count variable is incremented, and in the end, the count variable is written as the answer. So let's see if it gives the right solution. Okay, so it has passed all the cases, but the complexity is disgusting. So we will be improving it later on. Let's submit it and see where our code ranks. Because this is a pretty bad code written here, because the complexity here is clearly O of n cube. The space complexity is negligible because the only variable used here is count is equals to 0. So the space complexity would be O of 1. So let's see if we can optimize the time complexity. So here is the most optimized solution. We have reduced the time complexity from O of n cubed to O of n squared, which is a pretty significant achievement, because I don't think there is any more optimal solution for this. If you have any, please suggest in the comment box. And the space complexity of this question is O of 1 as well, because we are not creating any array or any hash set of any size that is comparable to the input variable here. The space complexity is constant, so it would be O of 1. Now in this question, what happens is that we have the description here as the following, and here I have simply implemented a count variable which would be counting the number of square triples in the range given here. I have implemented a for loop which would be traversing till n, and it would be circulating the values of all the integers present in this range and putting it into this variable right here. And similarly, for the variable b, I have implemented another for loop which is a nested loop, and similarly I have created another variable that is c2, and it would be storing the square of the sums of these numbers, or I should say the sum of the squares of these numbers, which is more appropriate. And I have created another integer c, that is the square root of this sum obtained right here. And the main idea is that if c equals c2, then the number that we got here was already a perfect square. This is because after square rooting this variable, we can get something that is a floating point number. So if we downcast it to the nearest integer value and store it in this variable, and after comparison, if both of these are equal, then means the reduced value was 0. So that automatically means that C was equal to C2. And since we have implemented another condition, that is C is less than equal to N, due to the fact that sometimes the sum of these numbers can expand the square of this target value here, the target integer that is given here. For example, if we take the case of n is equals to 18 and a is equals to 12 and b is equals to, let's say, 16. So after performing these operations, we find that c is equals to 18. C is equals to 20. And we can already see that this should lie in between the range from 1 to n, and it is already exceeding the n. So this condition was mandatory to implement, and after implementing it, we have implementing it. We uh, After implementing it, we have declared this statement right here, which increments the value of count. And after successful completion of this loop, we return the final count. And as I mentioned earlier, the time complexity of this solution is O of n squared, and the space complexity of it is O of 1. So this was the most optimized solution as of now. And if you have any other suggestions, please comment in the comment box. So that's it. Signing off.